Hello, everyone. Welcome back.
So now let me chair this session 1. And the speaker is Professor Stephen Maguire. He's a professor of University Sydney Business School, and he's also a member of Sydney Nano, Australia. And his title of his talk is Integrating Social Science with Nanoscience for Sustainable Future. Please, Professor.
Thank you. And thank you to the conference organizers. It's an honor to be included among such accomplished scientists and science policy leaders. I'm going to introduce the inaugural Sydney Nano Catalyst project called Engage Innovation Scholarship, and I'm going to put it into some context. So sustainable development as a concept inherently mobilizes both natural and social scientists. To assess environmental, economic, and social pillars of sustainability requires value judgments and possible trade-offs. So I like to conceive of sustainable development as a societal ideal, much like democracy, freedom, justice, towards which advances can continuously be made, but the concept itself is contested always and continually reoperationalized. If you think about our own lifetimes, questions of voting rights, the notion of democracy is reoperationalized and continues to evolve. Consider our session, which is organized around Sustainable Development Goals 8, 10, 16, and 17, which reference decency of work, inequality, peace, and justice. Now, advances towards sustainable development can be made via upstream, midstream, or downstream actions as concerns technological trajectories. In terms of upstream interventions, governments can fund in advance what they believe to be cleaner technologies. But there's always the chance of negative externalities and unintended consequences. In addition, definitions of clean can evolve. If you think about the world of chemicals, only in the past 30 years has the hazard endpoint of endocrine disruption come into existence. So there's often a need for downstream interventions, which might include taxes on polluting technologies, regulations to reduce these negative impacts, or funding for remediation. Midstream interventions, this refers to real-time funding of socio-technical collaborations to ensure responsible innovation. And responsible innovation refers to innovation which is reflexive about the impacts of these new technologies and seeks, wherever possible, to anticipate impacts and risks to stakeholders and to respond to stakeholders' concerns. I'm going to talk about an example of a midstream intervention, which is the Engaged Innovation Scholarship for Impact project at Sydney Nano. What we are doing essentially is studying innovation, so producing new scholarly knowledge by embedding business school researchers, design scholars, ethicists, anyone interested in innovation in the making, embedded in the labs, in projects, working alongside natural scientists, engineers, and biomedical researchers. But while we are studying innovation, we hope to catalyze and contribute to responsible innovation. So contribute to the innovation activities of scientists, engineers, and biomedical researchers. Examples might be delivering pedagogy on design thinking, on startup financing, how to engage overlooked stakeholders, or determining and accessing relevant policy or regulatory knowledge. We hope to help inventors and teams to become more business-minded and customer-focused so their research is more easily de-risked and commercialization ready. and in the event that the technologies may pose novel risks, to make inventors and scientists more societally minded and stakeholder focused. Cultivate a responsible innovation mindset and an entrepreneurial culture across Sydney Nano. So we engage with multiple teams or labs that are affiliated with Sydney Nano. What role do we play? Well, this figure comes from Fisher et al. 2015 and is useful for thinking about multiple roles that social scientists can play when they're embedded into inventing teams. On the x-axis is reference to capacities, or what can be done. And the native capacities represent the capabilities of scientists, engineers in the lab. At the other extreme are alternative capacities. These are the expertise and the capacities that social science researchers bring, or others from outside the lab. On the y-axis, this refers to values, or what should be done. So at the bottom, native values. So how do scientists and engineers currently frame what they're doing? How do they define desirability? How do they operationalize sustainability? At the top refers to alternative values. So bringing in additional considerations, helping scientists to perhaps reframe their technologies or consider a broader set of values. So in the lower right quadrant, facilitate, this might represent upskilling. So not challenging, not bringing really new capacities and not challenging framing or values in the lab, but simply helping scientists do what they've stated they want to do in an instrumental way, upskilling them in terms of collaborating across different disciplines, improving communication skills, improving their pitching skills. In the lower left quadrant is augment, so bringing some new expertise or capacity. So for example, bringing design thinking with a focus on users and customers, bringing business model development, skills and expertise. Upper right, problematize. Here, the goal is simply to make scientists more reflexive about values that they may be overlooking as they carry out their work. Additional considerations. And then finally, reform. These are interventions such as engaging stakeholders or design thinking workshops that bring in not just users, but all stakeholders who may be impacted by the new technology. Now, responsible innovation can be augmented in any of the four quadrants. And the history of the concept of responsible information, its history is in social studies of science and technology, ethicists, people concerned about the innovating the right way, getting technologies right. So most of the work to date has been focused on ensuring that innovation is responsible. Our approach, originating in the business school, is slightly different, and it stems from my frustration of working with green chemists and seeing all of these amazing chemistries with potential environmental benefits. But there's no environmental benefit until the chemistry is implemented at industrial scale. So whereas legal scholars and ethicists focus more on getting the technology right, our focus, if the technology is right, is on getting the technology out of the lab and helping scientists, engineers, and biomedical researchers to commercialize their technologies more quickly with less hurdles. So if you're not sure about the social desirability of your emerging technology, well, social scientists can certainly assist you. If you are sure about the social desirability of your emerging technology, well, there are no positive social impacts, no environmental benefits until your technology is out of the lab, commercialized, and adopted at industrial scale. Again, social scientists can assist you. So, consistent with Sustainable Development Goal number 17, which references partnerships, let's work together for a sustainable future. Thank you.
Thank you, Professor. Yeah, we understand the importance of the social science when we conduct the, or we intend to develop, to realize some innovation in technology. But it's not so easy to communicate with people in social science. And because of the difference of terminology and language, and also difference of culture. How do you overcome those barriers? Is there some meetings or some special?
Well, I would say it takes time and it takes dedication. It takes what might be termed boundary spanners. So I'm a social scientist, but my undergraduate training is in chemical engineering.
Mm-hmm.
And so I speak multiple languages, if you will. And I've focused almost my entire career working on social science perspectives related to chemicals management.
Mm-hmm. Okay, I see. So multiple disciplinary is very important, I think. Okay, thank you, Professor Maguire.
Thank you very much.
Okay. Next, we would like to move on to the Dr. Q&A question. Okay, sure.
Right. Sorry, Professor Sone, I was sending them in the chat. Stephen, we have a question from Professor Main. She's interested in the ways in which this initiative can be developed, can develop this changed mindset and broader social science capabilities in scientist inventors. For example, did the scientists go through courses or workshops?
We're currently working with individual teams and documenting their current situation and their needs as mutually defined. So we don't impose workshops. We may suggest workshops. It's currently highly customized.
Those are all the questions I received, so I'd like to move on to the next speaker.
Okay. So thank you, Professor Stephen Maguire.
Arigato.
Arigato. So now I would like to move on to the next speaker, Dr. Marc Fortin. He's Vice President of Research Partnership at Natural Science and Engineering Research Council of Canada, NSERC. And the title of his talk is the role of NSERC is supporting and shaping the Canadian research ecosystem. So please, Dr. Marc Fortin.
Well, thank you. Thank you, Dr. Sone, for the introduction, and thank you, Charmaine, for the invitation, Shihandra, for organizing this. We're pleased to be part of this discussion, and it's perhaps fitting that I'm presenting my remarks after Steve. I think you'll see some connectivity. I hope you do see the slide, and I'll move the slides to the next one. I'll just provide a little bit of context in terms of who we are and what we do. The Natural Sciences and Engineering Research Council of Canada is the funding organization that supports natural sciences and engineering research across the country. Every year we support approximately over 12,000 researchers, 37,000 students, and we support as well research and partnerships with close to 4,000 industry partners. So we support both fundamental research as well as the fundamental research to generate new knowledge, as well as the application of that knowledge in partnership with industry and other partner organizations. Dr. Ardem, in his comments a little earlier in the opening of the session, mentioned that NSERC has invested roughly $500 million Canadian dollars in nanotechnology research over the last 10 years. Our investments continue to increase year after year in this discipline. We provide $24 million. We have provided $24 million worth of scholarships to train the next generation of nanotech scientists, and researchers, and innovators. We've invested over $100 million of research support for research done in partnership with industry. So not only the fundamental research again, but the application of nanotechnology in an industrial setting. $31 million of research shares to create those nuclei, those centers of excellence, so to speak, where great science where we can create poles of attraction for great science. And this does not count the investments that have been done in research infrastructure that is done through different channels in Canada, as well as the investment done in the medical sciences, again, done through different channels. For us, we're looking at nanotechnology as a foundational science. The reason we're saying this is that nanotechnology will find applications in so many different sectors of society or of the economy. Material science, energy storage, and Dr. Sone earlier has made a good case for how many different applications there are for nanotechnology. And the University of Waterloo, of course, has done a good job at connecting nanotechnology science and nanotechnology developments to many different sustainable development goals of the United Nations. So on that basis, we do believe it is a foundational or horizontal science and enabling technology. The points I would like to make now is really to focus on the topics of this panel, that is nanotechnology and the interface to society and policy. I myself am a researcher, was a researcher, a scientist. I spent most of my career doing research. Unfortunately, not in the exciting field of nanotechnology, because when I grew up, that field did not exist as such. But I did spend most of my career doing research in genetic engineering and molecular genetics. And I'll make a connection in just a second. The first point I'd like to make is about the horizontality of nanotechnology and its different applications in society. That horizontality of application of nanotechnology will require that we engage horizontally across different civil society sectors. We, the science community, the research community, will need to engage with regulators, will need to engage with government, with policymakers. Engaging is not something that the research community does naturally, or I'm sure there are some individuals who do that naturally, but by and large, this is not an activity that we engage in naturally. The research community typically focuses on research, focuses on publishing the results of the research and getting more grants to do more research. This is fine. We need to continue to do that, but over and above this, we need to engage governments, regulators, policymakers. I will go back to the example of genetically modified organisms, genetically modified food. You may remember the debate some years ago. And I think one lesson we have learned from that experience is that we, the research community, and I was part of it, so I'm not pointing the fingers at other people, we, the research community, failed to engage those policymakers and those regulators and civil society writ large. And as a result, we have seen barriers erected to the deployment of that technology, regulatory barriers, legislative barriers, trade barriers in different countries. And those barriers were not always erected on an evidence base that was solid. And still today, some of those barriers exist. And that is 30 years after the commercialization of the very first genetically modified food. It was in 1990 that the first GMOs were put on the market on the consumer market. 30 years later, we still see biases, barriers in relation to the genetically modified food. And those barriers are not grounded in evidence because the evidence base for the safety of genetically modified food has been built over 30 years, where I think we can say with a fairly high level of confidence what is safe and what is not safe. So failure to engage of the nanotechnology research community to engage with regulators and policymakers very, very soon may well result in barriers to the adoption of technology that are not grounded in evidence-based policy or regulatory frameworks. The future applications of nanotechnology depend on how well we engage horizontally across sectors of society. There was a question earlier, how do we do this? There is no magic recipe, and Steve has mentioned design thinking workshops, ideation workshops. We at NSERC are exploring different ways of doing this, and Steve would be very, very interested in connecting with you and learn from your experience. But we must urgently develop those ways of bringing together the research community that sees a future that is very, very interesting and very compelling. But that future needs to be shared with regulators who typically will be more cautious. The second point I would like to make, I've just talked about the responsibility of the research community to engage horizontally. The second point I'd like to make now is about the responsibility of research funding organizations to work horizontally. And now that I've transitioned from a research lab to a senior position in a research funding organization in Canada, I can say that we are not doing this very well either. We absolutely need to be more horizontal in our approach to funding research, the applications of research. We need to facilitate research work across disciplines. We need to facilitate the work of nanotechnology materials people, nanotechnology sensors people, with social scientists, with health scientists, and again, go beyond that and involve the policymakers and the regulators. I will not claim that we have the solutions again for doing this. However, what I've put in the slide here are two initiatives that we have developed and are developing. And the first one is to enable university researchers to collaborate with both national and international colleagues. So at the national level, we've created something called the Alliance Partnerships Program, where we're funding the work of the joint work of researchers with knowledge users. And the knowledge users can be industry players, but they can also be, of course, government organizations, regulators, policymakers. In an ideal partnership, in my own mind, in the context of nanotechnology, we would bring nanotechnology researchers across different disciplines with industry players, industry users, with government organizations. And the reason I'm saying this is because we would then have the cutting edge science connected with potential uses in industry and connected to regulators and policymakers who can then facilitate the adoption, the safe adoption of those technologies, the safe applications of those technologies, because they would be ahead of the curve, so to speak, instead of behind the curve. They'd be ahead of the curve by witnessing the work that is happening in research labs, witnessing the applications that industry is contemplating. Those alliance partnership grants are currently available. That program exists. I have to say that we have not yet seen a great deal of uptake for creating those ideal partnerships that I was just talking about, that is, researchers, regulators, government organizations, and industry. We'll continue to push. We'll continue to certainly make those available. We have close to $300 million a year to support those partnerships. It's fairly significant. The other partnerships that we want to support, and that program is in development. It is not quite yet available. So I am proud to say that the University of Waterloo is getting a premiere or a early reveal of the work that we are doing on international partnerships, and that is to support Canadian researchers to work with cutting edge, leading researchers around the world to accelerate the research and to accelerate the application of research as well. So more information to come on the Alliance International component, but this is something that we believe strongly in. Canada is very proud of its investments in nanotechnology, witnessing the excellence of the research labs that we have here in Canada in nanotech, but also witnessing the quality of the talent that we train through the support that NSERC provides. So we've made some very important investments over the last decade in nanotech research. Top-notch research teams, top-notch research personnel. And now we need to connect that extraordinary talent and that extraordinary knowledge with industry players and with regulators and policymakers. We've committed resource to that effect, $300 million through the Alliance Partnerships Program. And we also need to connect horizontally researchers and other organizations across the world, around the world, to accelerate the impact of our investment. I will stop here and be happy to entertain questions, if any. So thank you, Dr. Sone.
Yes. Thank you, Dr. Fortin. Yeah, excellent talk.